In this video, I'll discuss incident containment. So when something negative happens, what is the incident response plan? Which role do people have and what should they perform as tasks to contain an incident? So we're talking about stopping some kind of a malicious attack, where we can resume business operations as quickly as possible and limit damage to sensitive IT systems and data. An intrusion prevention system, or IPS, can be used at the host level or at the network level. Either way, an intrusion prevention system will detect anomalous activity. Now, that can only happen if it knows what normal activity is for usage of an application or usage of the network. And we can configure it for our specific usage in our environment, which is usually what is required. But an intrusion prevention system can not only detect and log and alert administrators about issues, it can also be configured to take steps to prevent it from continuing, such as blocking firewall ports or shutting down certain services. Containment techniques include things such as segmentation, where we might isolate a machine or an entire network from the rest of the network, for example, if we detect a malware infection. Now, part of the incident response plan might dictate that a network technician unplugs a switch from a master high level switch in the hierarchy to prevent the spread of a worm. There's also the removal of problems, such as the removal or eradication of malware on a machine, perhaps by booting through alternative means, because often you can't really cleanse a machine correctly, at least completely and entirely, from malware infections without booting through alternative means, because sometimes operating system files themselves are infected and spawn during startup. In some cases, reverse engineering might also be used for incident containment to take a look at, for instance, what a piece of malware did so we can learn more about it to prevent future infections or to build effective anti-malware scanning tools. When containing incidents, we need to ensure that the attack is properly contained and ideally stopped in its footsteps. So we could unplug malware-infected devices or networks. We could block wireless device connectivity, for example, by jamming transmissions or using a Faraday cage or bag. We could also remotely wipe mobile devices that are lost or stolen to prevent data loss that is sensitive getting into the hands of unauthorized users. If your environment is using PKI, public key infrastructure certificates for authentication to services, then you could revoke the PKI certificate, for example, for a user account that we know is breached, or if there's a PKI certificate tied to a smartphone that's been lost or stolen, we can also, in addition to wiping the device, revoke the PKI certificate. Revoking a PKI certificate is similar to revoking a driver's license. It's no longer valid and cannot be used. So this would prevent connectivity to services requiring PKI certificate authentication. We could also take servers that are compromised offline immediately. Now, we need to have a plan in place ahead of time so this is done properly and that we have some other way of continuing business operations, such as a failover solution being in place if we have to take a server offline. In some cases, we also need to make sure that we preserve the integrity of evidence that might be used in a court of law, so it needs to be admissible. We want to make sure that that evidence isn't tainted during containment. So we might generate unique hashes of original data and then work only with copies or backups of that data. So we always have the original data at the time it was seized in its original form. The chain of custody needs to be followed so that we've got documentation that might also include how chain of custody was followed, such as file system hashing and preventing evidence from being tampered. We should be able to track where evidence was, how it was contained, where it was stored, how it was moved, and so on. And this might be required for evidence admissibility. In this video, we discussed incident containment.